Mr. McCarthy, we're going to have to ask you to leave. Your credit just ran out.
One more pull. I gotta win. Jackpot. I need jackpot.
Mr. McCarthy, think of your family.
Oh, the jackpot is for my family. Hey, let me go. Hey!
A lot of people think statistics is confusing. They see the formulas and get intimidated. Well, when it comes down to it, statistics is a language test. The math is very simple. You just need to understand the language.
There are a couple ways for us to look at the word statistics. First, let's think of statistics in the big picture.
So say you've got a bunch of numbers, or what we call numerical data. Statistics is the science of taking out a portion of that numerical data, studying it, and figuring out what that portion of numerical data tells us about the data as a whole.
This leads us to our second way of looking at statistics, or shall we say, the little picture.
The broad science of statistics is composed of lots of itty-bitty statistics. It's a classic case of the part making up the whole.
For instance, let's take another look at the big picture. Statistics is a lot like a pointless painting. When you look at it from afar, you see one thing.
But after a closer look, there's more than originally meets the eye.
If you're studying statistics, what you're doing is studying how to make sense of data.
Now that you have a grip on what statistics is, we can look at its components and learn how to use them.
The science of statistics is ultimately concerned with examining statistical problems. A statistical problem exists when there's something unknown about a population. A population is the group you're interested in learning about.
For instance, if you want to find the attitudes of registered voters, then registered voters is the population you're working with. A population doesn't necessarily have to deal with living things. It can be the ages of, rubber chickens, shoe sizes of teenage males, or number of minutes lying unconscious. It can be pretty much anything, really. It's just the group animate or inanimate that you need information about.
For example, meet the entrepreneur Charlie Cashmere. He loves cashmere. He loves cola. So, being an entrepreneur, he wants to combine his two loves into one super product. Cashmere Cola. Cashmere Cola. Cashmere Cola, yeah.
Charlie wants to know if his new soft drink will be a success. He needs to find out what percentage of the United States population might enjoy Cashmere Cola, which is the beginning of a statistical problem, my friends. Charlie starts the statistical population, the large group of people from which you can gather data. And who does Charlie want to gather data from? Soda drinkers, that's who. So the population is all the soda drinkers in the US of A.
From this population, Charlie will get a bunch of information about their likes and dislikes.
He'll then take this information, this data, and draw some conclusions. In statistics land, these conclusions are called inferences. When you make an inference, you're taking one piece of data and using it to draw a conclusion about another piece of data.
It's like when your grandmother is trying to get you a birthday present. She might find someone in the store that looks about your age and ask their opinion about something. If the person likes it, your grandmother will infer that you'll like it too.
Oftentimes the statistician, or in this case Charlie, is faced with a population that's virtually immeasurable due to extreme size. There's no way Charlie could get every soda drinker in America to try Cashmere Cola, then report their reactions to him. When this happens, the solution is to take a sample from the entire population and use this sample to make inferences about the population as a whole.
To try and gauge the reaction to his cola, Charlie can use a sample. A sample is a part of the population, in this case, a part of the population of soda drinkers.
Got that? Our population is all the people in America who drink soda. A sample is a randomly selected portion of that population. We take a sample because its smaller size makes it easier to deal with.
In order to solve statistical problems like Charlie's, there are certain things that must be established. These are known as the elements of a statistical problem. There are 5 of these elements.
To solve a statistical problem, there are 5 general steps you have to follow. We'll give you an overview of these steps now, then go into more detail as we move on.
Step 1. Identify the question being asked and identify the population. In Charlie's case, the question is, do you enjoy Cashmere Cola? And the population is all the soda drinkers in America.
Step 2. Determine the design of the experiment. Will you be able to use the entire population, or will you have to be like Charlie and choose a sample from the population?
Once you've figured that out, you need to figure out the best way to collect data from the population or the sample, be it by survey, field research, etc.
Step 3. Establish the method you'll use to collect and analyze your data.
Step 4. Choose a procedure for making inferences about the population or sample. These inferences and predictions center around probability. There are a bunch of ways to interpret data and find probability.
And finally, step number 5. See how reliable the inferences you've made are. So you'll need to set up a way to test the accuracy of the inferences and conclusions you've made.
Cashmere Cola, yeah. Cashmere Cola, the only cola with a silky smooth taste of cashmere.